So for this problem, we'll be working on a linear regression model. Linear regression model. So here we'll basically just build a simple machine learning model to predict. Let me see. We have to predict humidity. So we given the time as strings from 2015. We have the year, month, and day at different times, hours. 2015, 2015, 2015. Yeah, you see that the time is changing. We have from 7, 8, 11, 12, 13, up to 2 p.m. We have data taken at different times, and this data that was taken was humidity at different points. We have 2021 up to 27. So we have different humidity times taken, and the question says predict how much humidity will be for this time stamps here, right? So to understand this, we have to develop our linear regression model. And we know that the linear regression model follows the equation of a straight line, which is y is equals to mx plus c or b, depending on where you did your foundation in mathematics. It's still the same thing. So m basically represents the slope, and b or c represents, let me say b just to be clear, or c represents the y-intercept. Y-intercept. So from the equation of the straight line, we know that if we given this data here, and the aim is to fit this data here into our regression line, the straight line, then we know that from here we can get m, which is the slope, b, which is the y-intercept, and if we have this 2 here, the only missing parameter will be x. And if I give you x and say, given this x here, prediction time, predict your y, then it's easy to just substitute your values and put m, which is your slope, b, and your x given here, and predict y. And you see from here, y is a dependent variable, which is humidity in this problem, humidity. And your x represents your independent parameter, which is time for this problem. We also realize that plotting this data here will not be a straight line. So we know that our linear regression model has a larger bias because this data here will not curve, this line here will not curve with this data here. In fact, we'll have a certain error that needs to be minimized. So what we'll do throughout this, the error is basically the distance of each point from the straight line. So what we'll be trying to do is minimizing this error in regression model. So I'll jump into solving this problem, but before I do that, I've divided this problem into 2 sections. It's straightforward actually. So the first section is basically just fitting our data into our regression line. The data is given, so we just have to fit our data. So as soon as we're done fitting our data into the model, then the next part will be to predict the humidity for this given time, right? But I also added one extra step here. Since we're dealing with a date time and the time is given in strings, I know most people struggle with converting this data to time steps. So we have to convert. I add convert date time to time steps. So this is basically the time since epoch, right? So this is basically the time since January, Jan 1st, 1970. Jan 1st, 1970. So we'll do this for both the given time and the prediction time. This will make it easy for us to just pass through the data when developing our regression model, right? So starting our code, we'll just write our function, define. So we'll call our function, since we're predicting humidity, let's call it humidity prediction. Humidity prediction. Then our function will take in the given time. Our function will take in the given time. We'll take humidity, the given humidity. So this is the measured data. the time we'll be using to predict time, the new humidity values. Right. Perfect. So for this problem, we'll also use some Python libraries for our machine learning model. So first we'll import. Since we're dealing with time and date, let's import date time. And for our numbers, we'll also import num pi as np. And for our regression model, we'll import sk learn dot linear model. Here we'll import, so from this, from sklearn, we'll just import linear regression. Let me run this and check if the spelling is right. Perfect. So now the first thing I'll do is, let me just show you how to convert this data to timestamps, because we'll be playing around with that. I feel like this is the main part for this problem. As long as you can convert this data, then the rest will just be easy. So the first thing you do to convert this, remember our time data is in strings, right? I'll just say dt is equals to. So since our data is in strings and we have multiple indexes within this data, it's not just one timestamp. We have 1, 2, 3, 4, 5, 6 within our array, right? And the data set could be bigger than this. So let's just assume we have a bigger data set. So for this, we'll just create a for loop to traverse through this array of time given, and at each index convert the date to an object, right? So what we'll do is we'll use date time dot date time dot date time, and for this to convert our data from strings to an object, we'll use stir p time, which will take in each index within our array. So we'll say index I and create the for loop. So remember, one thing I shouldn't forget here is, remember here for each index we have to give the format for the time, right? So we have the time as year, month, day, hours, and minutes, right? So for that we'll have year, then we have month, then we have day, and now we have hour, and next we have minutes, right? So this is the format for the given data. Yeah. So to account for this I here, because it hasn't been defined yet, we'll have for I in given date, given time. So now this basically converts the given time from string to object. Let me just print this and see if I haven't done any spelling mistakes or syntax errors. dt, it looks okay. Perfect. So now we have our data converted from strings to an object. So after this, we still have to convert it to timestamp, since we're saying we're converting it to this to be able to pass through it during our model, right? Time is equals to. So we'll create another for loop here, but here let's use date time dot date time dot spelling date time dot time stamp. So here we're converting the given object, the object we have here, to timestamp, right? And to do that, this dt here will still be in a form of an array. So we have multiple indexes within this. So we'll traverse through each index, let's say j, and jump to our for loop for j in. Now we're not dealing with given time, we're dealing with dt. So we'll say for j in dt, right? For j in dt, let's get the timestamp. Okay. Let's see if it will print out our timestamp. So remember, this is seconds from epoch, right? So it'll be thousands of seconds from epoch, since it's from 1970 to 2015. Let me run that. Perfect. So now we have the seconds. We have all our data converted. So we'll take this to our function and start building our machine learning model, right? So we have our time to work through. So now that we're done with the first step of converting time from here, now we jump to creating our model and fitting the data. So to create our model, it's as simple as this. Using our Python libraries, we just say regression is equals to linear regression. That's it. So now that we have our model created, we just have to fit regression, fit. We have to fit our data into this model. Remember, as I mentioned here, we have this data here. We have to fit it into our regression line so we can get our slope and y-intercept and be able to use the time to predict y, which is dependent on x. And y here in this problem here is humidity, right? So to be able to fit our model, let's use the array of time we just built right now, the array of time, that's our timestamps, the array of time, and now we have to reshape this. The reason we reshape this, we reshape it to the original data that's given, and we know that our data has one row, reshape, but we have no idea how many columns it could be, endless. So since we don't know how many columns we have, we can just say -1, but we know how many rows, then we can just say 1. np time dot reshape, perfect. And here we have our dependent variable, which is humidity. Regression model fit np data. Okay, so from here we can get our coefficients, which is our m, so np. Since we have our data fitted into our linear regression model, and now the next thing we do the same thing we did here for the given time, we have to do for the prediction time, because the prediction time is still in the same format of strings. So to do that, we take the same line of code. Let's name it prediction. I'll just say PDT. We know P is prediction. P time. It's prediction time. Same thing here. I'll say, instead of dealing with I, will say K. Then we say for K. Now our data is not from given time. Remember, now we're working with the prediction time. So we say predict time, K in predict time, in prediction time. Then let's say L for L in prediction object. So this is the object of our time. Right. So if we have this, now we're just converting our time to timestamp so that we can be able to predict the humidity at this time steps. So now that we have our time sorted, let's go back to our model and say we are done. Let's predict. Let's use our model to predict, regression model. Predict time. So np array of what? Of our prediction time. It's p time, right? Perfect. So now that we have that, we still reshape this data as per the original data. Reshape. We have no idea what our column is, how many columns we have, but we know we have one row. Prediction time. So this is it. This is the basic linear regression model. Let me delete this and run it, see if we have everything working perfectly. Okay. It's running properly. So what we're expecting from this model here, we should be able to get humidity values for these dates here, right? Notice that the given data of humidity is 2020, 21, 22. So if we predicting it, see the end was at 4, 5, 6. Basically, it should still be around the 20s, right? It should still be around the same humidity values because it's not far off. The only difference is like one hour difference for each, right? So if our model is perfect, then it should be those. Perfect. So see, we have the predicted values as 26.8 and 27.8. So we still have the same trend we have from the given humidity data. So this shows that our machine learning linear regression model is working perfectly. So what we can do is we can change. Let me say I decide to change the year and say, okay, if we know that in 2015 this is the humidity we have, then let's use our machine learning model to predict how much humidity will be in 2020. It's 2020. Let me say in 2021, same time. 2021, same time, right? So now I'm just changing the prediction time and see if our model can be able to give us humidity data for this time in 2021, right? So humidity in 2021 will be, it goes up to 4,000, right? So obviously, if we go following the experimental data, we understand, if we understand where we got this experimental data, we know this is obviously wrong. This is why we need to find a better model than the linear regression model, since we have a large bias for this model. Great.